Okay, today we are going to find C. Now, what we did yesterday was finding the antiderivative, so that means we know y dash, which gives us the derivative, and we're going to figure out what the original function y is. So if we look at that, x squared, of course, is going to go to x cubed. Then we think about it in reverse. When we differentiate that, that's going to be 3x squared. We don't have 3x squared, we've got 18x squared. So we need to times that by 6, right? So 6x cubed differentiates to 18x squared. So we've got that. And then this is x to the power of 1. So we add 1 to the power. That's 2x squared. Now we think about that, if we're differentiating that, that's going to be 2x. We don't have 2x, we have minus 4. So we multiply 2 by minus 2 to get minus 4, right? So minus 2 needs to go in front of there. Let's just double check that. Yep, 2 times 2 is 4, that's correct. And then of course 7, that just comes from 7x, right? 7x differentiates to 7, fantastic. And then we have plus c. And so, of course, if we had no more information, we wouldn't be able to find plus c. But today, we have some extra information because we know this now, y equals all of this. That's a graph, that's a cubic. It's going to look probably something like that. And we know it passes through this point here. So if we were to plot that on a coordinate system, maybe it goes through there, -1, -8. So now we know it's specifically going to look like that. It's not there or anywhere else. It's in a specific place. Okay, so this plus c, that is going to be a specific number. Okay, and so then we think about what's going on. We know it passes through -1, that's the x value, -8, that's the y value, the y coordinate. Okay, cool, so all we need to do, substitute in for x, substitute in for y, and we're good. Now, because I'm solving for c, I'm going to put this around the other way. So I'm going to write it all down. So now you can see I've just substituted in x is -1, so 6x cubed means 6 times -1 cubed, x squared, so -1 squared, and 7 times -1, easy. And then y is equal to -8, so there's y is equal to -8. I've just swapped it around that way because I'm going to be solving for c. Okay, now this, like a whole bunch of other things, that really is just a matter of being careful, just reminding ourselves -1 cubed, right? If we write it out long form, that's -1 times -1, which is just +1, times another -1. So it gives me -1. I've put it in brackets there to remind you guys that if you're doing this in your calculator, you need to put the -1 in brackets. So this ends up being 6 times -1, okay, which is just -6. Cool. Doing things step by step rather than putting this whole thing in your calculator is always a good idea. And now I've got -2, and now we know -1 squared -1 times -1, that's +1. So that's 2 times +1, -2 times +1, so that becomes -2. And then, of course, 7 times -1, that becomes -7. So -7 there, plus c equals -8. So plus c equals -8. Now we could equals -8. We could do this two ways. We could add all those together first, or what I like to do is just go c equals -8. Then all of these are going to come to the other side, so it's going to be +6, +2, +7. And we've got that in our calculator. Add that all together, so c equals 7. Just going to rub that out. Now, if we've just written down that, we haven't got our final answer, because now we know that c equals 7. We have to now rewrite what that original function is. So we're just going to rewrite what we've got up the top. Okay, plus 7x, and we're going to add the 7. Now it's positive 7 is what C is, so we write plus 7 there, eh? And that's our final answer there. Just a reminder what we're looking at graphically. So this is what our graph looks like. It's actually one of the cubics that doesn't go up and down, it just keeps going up, but that's fine. And when C equals 0, of course it goes through 0 as we move. When C equals 1, it's going through there at y equals 1. And so it's still the same shape, but it's just moving up and down. Okay, so now if we change C to what we got, which was positive 7, it goes through there. And when we put in the value -1, -8, as you can see, it goes through there. So if we change it back to C, you can see the only value of C that goes through that point, where is it? Let's go back to, there we go, is when C is equal to, sorry, not 8, it's when C is equal to 7. That's the only time it goes through there. Okay, cool. So there's only, when it goes through a specific point, there's only one value of C it could possibly be. Okay, so now we have another version of this type of question, but instead of having y dash, we've got dy dx, which is just the same as y dash, so we're going to be looking for y equals, and instead of giving a coordinates, we've got when x equals 1, y equals 7.5, so we could think about it like this. So it's exactly the same as before. We're going to integrate, substitute in x equals to 1, y equals 7.5, and then we can find C. All right, so why don't you guys pause it and give it a go. Now, when we're anti-differentiating this might be one of the ones, 5x might be easier to, so we add 1 to the power, because it's to the power of 1, and divide by that. And so that's going to be the correct answer, right? Because if I differentiate that, we've got 2 times 5x all over 2. The 2's are going to cancel out, and we're left with 5x. Cool? So, like I've been saying, sometimes using the formula kind of makes it easier. And then we know a number just starts from 3x and the plus c. Fantastic. So just double checking that. Yep, this differentiates to 5x and 3x differentiates to 3, so that's fantastic. This one, because we've got x equals positive 1, not negative 1, this is actually really simple. Again, we're going to flip it around. I'm going to have this first. Now, I've got 5 times 1 squared over 2. Now 1 squared is just 1. So 5 times 1 over 2, that's just 5 over 2, or 5 halves, right? 5 halves, or you could, I'm going to do it decimals over here as well, because some people are probably doing decimals, or you could write 2.5, right? 5 halves is 2.5. And then of course 3 times 3x, 3 times 1 is just 3, plus c, and then y, so plus 3. Plus c, and then y is 7.5. I'm just doing it 2 different ways just to show you. Sometimes it's easier just thinking about things as fractions. Now 7.5 is 7.5, which is 14 halves plus another half, so that's 15 halves, isn't it? Okay. Anyway, so now of course c is 15 halves minus 5 halves minus 3, or C is 7.5, 7.5 minus 2.5 minus 3. Okay, and of course, if we do 7.5 minus 2.5, that's just 5 minus 3. So the final answer C is 2. But really even easier here, if I've got 15 halves minus 5 halves, well, that's 10 halves. 10 over 2, what's 10 divided by 2? It's 5, so 5 minus 3 is 2. Okay, so again, it's just personal preference. A lot of the time, especially when you are starting to go into Year 13 calculus, just using fractions actually makes your life easier, even though at first you might be scared of fractions, but don't be scared of fractions. And so then if I've got C equals 2, I just rewrite the final answer, and that is my final answer there. I've just rewritten what I've written up there, but now I've put in C is equal to 2. By the way, of course, if you've written 5 over 2 there as 2.5, of course that's still correct, right? 2.5 x squared, that is exactly the same as that, because when I differentiate that, I get 2 times 2.5, which is 5, so that's fine. Decimals, fractions, the same. And then, of course, as well, you could also write 5 over 2 times x squared. All of those are exactly the same, yeah? 5 halves times x squared, 5x squared over 2, or 2.5x squared. They are all the same, okay? Anyway, and so again, there's our final answer. If we put the graph on Desmos and stuff, we'd see that it would only go through this point here. Okay, and now one more way that we see basically the same kind of question. These questions start getting a little bit trickier, but today we're just looking at these basic things. This is the same kind of thing. We've got f dash x equals, so we need to anti-differentiate or integrate to find fx, so we'll do that in a minute. And we know f of 2 equals 1. Now, because we know this is a function of x, what that means is x is equal to 2. So when x is equal to 2, fx equals 0. So in a way, fx is like y. So you can kind of think of it, well, you can think of it like a set of coordinates, where if you were looking at a set of coordinates now, and you have x here, instead of having y there, you put fx, you put the function there. So when x is 2, y is 0. Oh, that actually is right there, right? When x is 2, y is 0. So we're doing the exact same thing. So let's anti-differentiate there. 12, of course, comes from 12x. Now 6x, x squared, 2 times 3 gives me 6, right? So it's 3x squared. X squared, we're going to add 1 to the power x cubed. Now we're going to get 3 times minus 3 gives me minus 9 plus c. We'll do a quick double check. What are we doing? 12x differentiates to 12. 2 times 3 gives me 6x. Yep, that's right. And 3 times minus 3, that gives me minus 9. So that's fantastic. Okay, so we've integrated it right. Now we need to find c. By now we can do this pretty quickly. 12 times x, 3 times x squared. So x is 2, so 2 squared is 4, right? Minus 3 times x cubed, so 2 cubed is 8, so that's why I've got it like that. No worries. And this ends up being quite easy. 12 times 2 is 24, 3 times 4 is 12, minus 3 times 8 is minus 24. I preemptively crossed out the 24 because I knew that I'm going to get 24 minus 24. That's 0. And so all I'm left with is 12 plus c equals 0, so c must equal minus 12. We've got c equals minus 12, so now we just need to rewrite it by writing c is equal to minus 12 right there. And that is our final answer. Just a reminder, if you've done the correct integration, calculated c, but haven't then rewritten the whole function, you're not going to get the mark. This would be an achieved grade question. All of these were achieved grade questions. You can see there's not much to it. I'm just doing the so-called anti-differentiation, then figuring out what c is, which is normally not that complicated. So that'll get you a U grade in the exam. Okay, cool. Okay, so now what we should be doing is going through Walker Maths. Pages 56 to 57 are easier questions, just like what we've done today. So just do, if you do every second question, then that's only 5 questions, no big deal. If you want something harder, where we're getting into merit level and possibly even excellence level questions, try page 58 to 59. I haven't gone through those kind of questions yet. I will in the future. Okay, and of course, there's some more examples on page 55. Cool. If you've got any questions, send me an email, of course. Cheers. Bye-bye.